All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. And today we are going through the core Windows processes room inside the SOC Level 1 pathway of TryHackMe, which is part of the Endpoint Security Monitoring module. And as you can see, this is kind of a pretty hefty room. And it's one of those things that I think there is a machine that is attached. Yeah, we do have a machine that's attached, so I'm going to start that. And we're just going to kind of run through the processes, and we're going to hopefully learn some really cool things about endpoint security and monitoring. Before jumping into the introduction right here, I just wanted to kindly and humbly request that if you learn anything from me, if you learn anything from this video, if you like the content, and if you want to show your support, it would mean the world to me if you could like, subscribe, comment, turn on the notification bell, share it with your friends that might be interested in this. Any of those activities will help the algorithm find our channel more and put our channel out so we can get more reach. And from there, we can grow the community and expand our user and our accounts and our channel in general. So it would really genuinely mean the world to me. I don't ask for anything else. All of these things I do for free for you guys so you can get as much information as possible on cybersecurity, penetration testing, ethical hacking, so on and so forth. So that's literally all I ask. That's the only thing that I would request, and that's basically it. It would mean the world if you could actually do that. Now that that's out of the way, without further ado, let's jump into the introduction of the room. Okay, so basically the intro of the room says that we're going to be going into all the core processes, as the name implies right here, that is on Windows. And there's a line right here, you know, it's the most used system in the world. Windows is, whether people like it or not. And the majority of the users don't fully understand the workings of it. And I used to be that. I still am that. I'm not even going to pretend like I know how Windows works in and out. There's a lot of stuff that's available in Windows machines, and believe it or not, it can be extremely powerful to know how this whole thing works. So basically, people are happy that it actually works, right? Just like you can use a car to drive from A to B, you don't necessarily know how, you don't need to know how the car runs and does what it does, as long as it gets you where you need to go. So if the same thing applies here, right? If you can surf the web, if you can do emails, whatever, it doesn't matter. But if you understand the inner workings of it as a cybersecurity analyst, as an ethical hacker, it just puts you head and shoulders above everybody else. So one of the essential everyday computer functions is disrupted when antivirus matters. So if antivirus was enough over 5 to 7 years ago, but time changes and malware and attacks have evolved, right? Hackers have evolved. Everything has gone way past what the baseline was a long time ago. And 5 to 7 years is a long time in the world of technology. Like a lot can happen in a month in technology. So when you think about 7 years ago in tech, it's pretty crazy. So antivirus has struggled to keep up, obviously, based on how it's designed to catch, you know, evil, quote unquote. It's just one layer of defense. It's one layer of a solution. And things like EDR, endpoint detection, and response have been created because antivirus can't keep up. So even with all of that, it's still not 100% effective because attackers are coming up with new things every single day. They're trying to find zero-day attacks and zero-day exploits on a daily. So when you're a SOC analyst, a security analyst, detection engineer, threat hunter, whatever, if any of the tools alerts of a suspicious activity, we have to investigate to try to see what's going on and take a course of action. And the machine that is attached is going to be a split view if we can. We're probably going to go into full screen with this thing, and we can even access it via RDP if we wanted to, but I'm probably just going to keep it in my browser and keep it simple, because it seems to be, it seems to be just that we only need to do one thing with it. It doesn't seem like we need to do any kind of remote shell or any attacking directly. I think we're just going to be looking at the Windows processes themselves. So I'm gonna open this up in my secondary monitor as well. And then from there, we're just gonna go through each individual item that's inside this thing so that we can just kind of figure out how this whole thing works, right? So the first one, and I'll just open this in a full screen. So we have this right here. The first one is the task manager, and the task manager can be opened from the view, the taskbar right here. So do we have something right here? I think it's inside this thing that we can actually go to the task manager, and let's see, I might even be able to search for it. But it says to open the task manager, right click on the taskbar, and then, oh, so I can even do this. I could do that and then go from here, go to task manager right there. But there's a shortcut also that says Control Alt Delete. That's what we used to do all the time. So if there's nothing running, there's going to be nothing in here. It's going to be empty, right? So not seeing much is, I guess it's kind of weird. We can click on more details to see what else is going on. Look at that. Now we see a bunch of stuff that's actually happening in the background, right? These are the background processes. So you have that task manager itself. Let me zoom in a little bit for you, and then we'll just kind of move this to the side so we have access to it. So we have the task manager itself. We have all the background processes, and everything is under the default tab of processes. If we're running it on Windows, we might also see additional, if you're running it on your own Windows, you might see additional tabs and things like that going on. So we can notice that processes are, they are categorized as follows. So there's the apps process or apps category, which is the task manager itself. There's the background processes, and another category that we might be able to find if we go down are the Windows processes right here. And all of these things are just kind of running. The columns are minimal, as the course says. The column name, status, and CPU, which is name, status, CPU usage, is are the only things that are visible. We can right click on the column section here and try to see if we can find more options, or maybe click on status and then see if we can more options. There we go. So we have the type, publisher, PID, process name, the command line, CPU, memory, all of those things are available. Then there's the resource values, which is either values or percentages that can show you how this whole thing runs. And to make it, that view looks a little bit better. So I guess we should be turning that on, huh? So let's just try that on just to kind of see what else is going on. We got the type, we got, let me see, I got the PID I'm gonna run, I'm gonna add the command line, and I'm gonna add process name, why not? And so now I can kind of expand this a little bit just to show you what all of that looks like. And it's a little bit, I mean, it's pretty cool. So if I kind of shrink the status down a little bit, we can maybe even shrink the process name a little bit just to bring everything onto the screen. And so that's kind of what it looks like. And I think we can even drag these, yeah, we can drag these back and forth to organize them however we want to. So if I just go at the very beginning and drop the usage of this stuff at the beginning, all of the other things could be done secondary, so to speak, so that you can see a little bit more organized. So the type is each process files into one of three categories, which we already kind of saw: the background process, Windows process, or an application process that we see already. There's the publisher, which I didn't load, but it's basically the name of the author of the program, so whoever made the program. The PID is the process identifier, and it assigns a unique process to, or unique ID, excuse me, each time the program starts, so that you can modify it via the command line if you wanted to. The process name is the executable itself that's running, and the one that we're running is task manager exe, right? That's the thing that's actually running here. Then command line is the full command used to actually launch it, that you need to, if you wanted to run it from the command line, you would need to do the full thing, unless you're actually inside the system32 folder right here. Then you could just do task manager exe. But if you're inside the general root folder, then you would need to run the full thing to be able to open it up. CPU that we see now, we moved from here, is the amount of processing power from the CPU, the computer's processing unit, central processing unit. and that's the amount of power that it's using, and then the memory is the amount of physical working memory, the RAM, that it's actually using. So we don't have anything that's heavy that is using a lot of this stuff. If we go into the details tab, we might be able to see a little bit more interesting information, and we can kind of bring this up a little bit closer here. So you got running, there's one that is suspended, or a couple that are suspended. We have the username, which is assigned to it, which is system administrator, DWM1, network service, local service, all that, CPU usage, as always, memory usage, and UAC, user access control virtualization, either not allowed or disabled, is what we see as our options over here. So let's see what the text from the class says. Some additional columns to see more information. We can do the image path name and the command line. So I guess I can click on this one more time, or maybe click on this one more time. Nope. How do I add more details here? Here? Kind of doesn't really tell me. Doesn't show me how to do it. Good columns are I can't add it, so I don't know how to add it. That's the issue right here. Maybe it's under view. Updated speed, nope. Options, nope. File, nope. And if I do fewer details, then it shrinks that back down, so that's definitely not it. So we can just go back to this. Can I add anything right here? Oh, select columns maybe? There we go. That's how you do that. Okay. So from here, we can choose something called the command line and the image path name based on what they recommended to us. So image path name and command line, and do OK. And here we go. We got that too. So now this is where the path of whatever this thing is actually at the command line to run it. And there we go. So they can, these two columns can quickly alert an analyst of any outliers with a given process in the image PID 384. So in the one that's on the documentation of this room, is process with a name svchost, a Windows process. But if the image path name or command is not what it's expected to be, then we can perform a deeper analysis. So that's what they're saying. So if I click on this, for example, and I guess we find, so for us, it's 496, it's not 384 for the PID. But then you go here, and then you see that the executable path is svchost, and then the command line should also be svchost, right? That's basically what it should be. So when you see that, that means everything is all good. But if this was pointing to a different path, or if this command was doing something different that it shouldn't be, then you know that you need to investigate a little bit further. You can add as many columns as you wish, because as you saw, there was a bunch of stuff. It's a powerful built-in network utility, but it lacks certain important information when analyzing processes, such as the parent process, and another key column, which is, then we can go back to svchost and see that the parent process for this is not services.exe. So I'm sorry, back to svchost. If the parent process for it is not services.exe, then we want further analysis. So I guess I could just go back here again, do select columns, and see if we can find something called the parent process. And from that, we can see if it's actually connected to the parent process that's supposed to be connected to it, right? There's actually no item called parent process on here. So I think it's actually something that we're supposed to locate from here, right? So if you see that under the image path name, for example. So, okay, now moving on from the task manager itself, we're going to go into something called the process hacker. The process hacker is a different item that I guess we can open from our search down here. So if I went to my search box right here, there is no actual search command down there, so I would need to manually do this. And then from here, if we look for process hacker, there it is, process hacker desktop app. So that's going to open itself up, and it's going to show us a certain number of processes, and then there is the process explorer also. That is another thing that ends up helping us. And there is really not much with the process hacker and process explorer in this particular task. I think we're going to look at it a little bit later. So to see, as always, it's encouraged that you inspect and familiarize yourself with everything that's available in Task Manager. It's a built-in utility that's available for every Windows. You might need to find yourself in a situation where you can't bring your tools to the fight and rely on the tools native to the system. So these are the things that are native to the system. Aside from Task Manager, it would be good if we learn the command line equivalent of obtaining information about it on a Windows system, which is the task list, get process, or PS for PowerShell, and WMIC. So those are some of the other things. And since I've already loaded the process hacker, I'm just going to leave it on the screen right here. But we're actually done with the task for Task Manager. So the next thing that we're going to go into is the system. So we just finished Task Manager, and we're going to go into system next. Okay, the system, this is the first Windows process on our list, apart from the Task Manager, I guess. It was mentioned in a previous section that a PID for any given process is assigned at random, but that is not the case for the system process. The PID for system is always 4. So we can actually see that right here. The system PID is 4. So that, I guess, means that it's always going to be 4. The official definition from Windows is the system process, process ID 4, is the home for a special kind of thread that runs only in kernel mode, a kernel mode system thread. The system threads have all the attributes and context of regular user mode threads, but are different in that they run only in kernel mode, executing code loaded in the system space, where that it is the NTO whatever something exe or any other loaded device driver. In addition, system threads don't have a user process address space, and hence must allocate any dynamic storage for operating, such as a paged or non-paged pool. So what is user mode, kernel mode? They say visit the following link to understand each one. So we're not going to do that right now. So what is normal behavior for this process? We're going to use Process Explorer to try to view the properties of the system. So right now I am in Process Hacker. So I'm going to go back to search, and I'm going to open up Process Explorer. Okay, so I think that's non-existent. It might be this thing right here that is inside that window. So there we go, Process Explorer. And we have different versions of this. It says, I don't think it matters which one I use, but we can kind of use whichever one really. So let's just use process.exe, the first one, which is the full application. And it's gonna ask us if we want to agree to the license, and we should. And here we go. So it looks pretty similar to the process hacker that's right there. And so if we look at the system right here, the PID, it's on a different column, but the PID is number 4. And then there's a bunch of different information about it as well. And then if you notice, the difference between that and the process hacker is that at the top right here, we get these little graphs that actually show us how much of each things are being used. So this is the CPU, the system commitment, physical memory, IO, the network, disk space, so on and so forth. So there's a difference, I would say, probably significantly. I don't know fully yet, but we're gonna learn as we go along this room right here. So when we open up Process Explorer, we can view the properties of system. So I guess I can double click this. Can I double click that? Yeah, I can. So now we have the system properties. And inside the system properties, there's a bunch of different tabs. And the very first one on the image tab at the beginning shows us the path, the command line, and the current directory, which is all empty. and then the parent is none because it is the system, and the user authority itself is system. So that's kind of important to know. The information is different if we use the system properties using the process hacker. So if I push this to the side and go to this and double click that, it's a little bit different. It's not an image tab as the general tab or as the main tab. It's the general tab. So it shows us the kernel and system, and it shows the version of it. It shows the file name where it exists, the path where it exists. There is no command line, so as we already saw, the current directory doesn't exist, and the parent is the system idle process. So those are, it shows some similar information and definitely some different information. Specifically, the parent process, system idle process, that part is different, and of course the path I think is also different. So if we go over here and try to look at the path comparing the two, this one right here doesn't even have a path. This one seems to have a path. Let's see if there's any other information down here. No, but this one that pretty much has blank everything, and then the user is whoever that is, but that's pretty much all the information that we get. And so we have a decent difference between process hacker and process explorer. So you may notice that process hacker confirms that it's legit, verifying Microsoft Windows. And then what is unusual for this process would be that the parent process, aside from system idle process, so if this parent process is different, then we could see that it might be kind of sketch. There might be multiple instances of the system inside any of these things. So if you see multiple systems right here, and maybe even the PID is different, right? So what if the PID was different? That also should be sketch. And then it says not running in session 0. So that's another thing that might be sketch. And so I think that was, oh no, you know what? That's when we actually open this up and it tells us where it's running. So it might be in this thing where it says it's running in session 0. Can't find that information right now. Yeah, I don't see it. So where would we find if it was in session 0? Cannot locate that right now. But I mean, that's pretty much it. That's kind of the process hacker as well as the process explorer, looking at specifically the system process. So now that we can do that, the question at the bottom, it says, what PID should the system always be? And we've already established that, and it needs to be PID 4 is what the system should always be. So now we're going to go look at one of the child processes for the system, which is the smss.exe executable. So we did the system, and I'll just reload this just so you can kind of see that we actually have done these things. So we did the system, and the next one is the smss.exe. So let's try to find that inside our process hacker and process explorer. Okay, the smss.exe is known as the session manager subsystem, and it's also known as the Windows session manager, and it's responsible for creating new sessions. It's the first user mode that is started by the kernel. It starts the kernel and user modes of the subsystem of the Windows, and it includes the Win32k sys, the WinSRV DLL, and the csrss. And so the Win32k sys is the kernel, WinSRV is the user mode, and then csrss is also the user mode. So it starts csrss, which is the Windows subsystem, and wininit.exe in session 0, and it's isolated for the operating system. And it starts csrss and winlogon for session 1, which is the user session, and the first child instance creates child instances in new sessions done by smss, copying itself into the session and self-terminating. So we can read more about that probably when we actually get further along. And so session 0 is csrss and wininit. And that's the thing that I'm really trying to find out, is like, how do we find out if we're in session 0 or not? That's the part that I'm really interested in. But specifically, we have this section right here. So we can look at the wininit and csrss right here. So you have csrss and you have wininit, and then under wininit we have a bunch of other things that are currently running. And I guess we can click on one of these things to try to see where it's actually. There it is. Now I see it. So okay, it's not inside any of these views, but I just read the documentation and it showed it to me. So if I click on this, and if we go to the token, and it doesn't even have token as a tab, so maybe it's inside the process hacker. So if I click on CSRSS and then go inside token, voila, we should see session 0. And where would that be? It would be under the session parameter. Okay, so this one, actually there it is. So this one is actually in session 1. So let's see if the other one is in session 0. Yeah, this one is in session 0. So it says that on the system level, it'll be in session 0. On the user level, it'll be in session 1. So this one, since it's session 0, it would be on the system level. And then this one, since it's session 1, it would be on the user level. Session 1, so on and so forth. Another subsystem listed in the required value of the registry editor is also launched, and that is, I guess, called debug windows. And I don't know if this is available here. It would be interesting if we could search. We can search. So let's see if we can search for debug. Debug is not here. So, but it says, so let's kind of go look at the actual task instructions here. It says any other subsystem, not another. So any other subsystem listed in the required value of this section, which is the registry editor for that registry, is also launched. So if it's under the required section of this registry, that's also going to be launched. SMSS is also responsible for creating environmental variables, virtual memory paging files, and starts winlogon. So what is normal? It's going to be any of these options right here. So we can go back here and try to look at that information, and it doesn't tell me which version of this they used to check this. So we can do SMSS. Let me see if I can find SMSS. Maybe it's under processes. Of course, I can just search for it, which is probably a good idea. Find file handle SMSS, search, and we have a bunch of these things. So process, so on and so forth. So there it is. And there's 4 instances of this, I guess. But let's just open one. So, I mean, so SMSS, I guess, is the system itself, right? So this is not the view that we're looking at in the exercise file. This is the view that we're looking at in the exercise file. And so the general looking at it, this is what's normal, and it should be inside all of this. We already kind of viewed this. The process should exactly be as it is right now, and the parent should be system, which is number 4. So that's all normal. And then there is the unusual, which would be the parent is different other than system 4. The image path is different, more than one running process. So children self-terminate and exit after each new session. The running user is not the system user, and expected and unexpected registry entries for that subsystem. So the question that we have here is, aside from CSRSS, what process does SMS spawn in session 1? And if you remember, session 1 is the user session. So it's going to start winlogon.exe, and that is the answer to our question for this section. So now we're going to move on from the current task that we're in, and we're going to go into the next one, which would be the csrss.exe. Okay, so as mentioned in the previous section, client server run process, whatever this is. Why can't I zoom in? There we go. It's in the user mode sign of the Windows subsystem, which would be in session 1. It's always running and it's critical to system operation. If the process is terminated by any chance, the system fails and it's responsible for Win32 console window and process thread creation and deletion. For instance, this DLL, that DLL, and that DLL are all loaded along with others. It's also responsible for making the Windows API available to other processes and mapping drivers, handling Windows shutdown, and we can read more about it over there. The recall, to recall that winlogon and csrss are called for session 1, right? So this is what's going to be normal. So let's go and try to find the session 1, and this is the session 1 version of this. And in this particular one, we are looking at the process hacker view, and that's what they're also looking at inside the task instructions. And so this is what's normal, and this looks like normal. The command line is exactly what this should be, and that's also what's normal. The current directory is fine. The started time, we started this 30 minutes ago, so that's all good. The parent should be non-existent, which I guess that's also good. And that is the session 0. Is this session 0? So let's look at this. This is session 1. So this is session 1, and I mean it all still looks good because it's pretty identical to everything else. So if we look at session 0, it should also be pretty identical. So general, all that stuff is here. The root is pretty much the same. The Windows 32 is the same. Start time 30 minutes ago. Non-existent process. All of this is identical to each other. There's just one that's happening for the system, and there's one that's happening for the user. So it's saying in the file that notice what is shown for the parent for these two processes. Remember that these processes are spawned by the system, the SMSS, which self-terminates itself, meaning that the parent should be created by an instance and there should be nothing else there. So image path is the same that we just saw. Number of instances should be fine. User account is the local system. Start time within seconds of boot time. So meaning we started this thing 30 minutes ago. We started this machine 30 minutes ago, and it's approximately 30 minutes. That's when it was started. So an actual parent process might be unusual. So if it has an actual parent process right here, this is kind of weird, right? It shouldn't have that. The image file, if it's anything other than the system32, that's also sketch. The subtle misspelling to hide rogue processes that might be wrong. So if this is subtle, so CRSS might be sketch, you know? So it's like you just got to pay attention to the misspellings. And the user is not a system user. That's also pretty sketch as well. So that's basically it for this. Now it says, what was the process which had a PID of 384 and a PID of 488? So in this case, let's see if we can organize by 384 and 488. I don't have either one here. And what if we organize here? 384, 488, I don't have it here. So in this particular case, I'm guessing they're talking about their own, yeah, they're talking about the specific task file itself, right? So here, 384 and 488 are probably not, obviously they're not here because both of these have different PIDs. So if we go here and try to find the PIDs for these things, we could probably find something different. None of that stuff is available here either. So I wonder what they're referring to when they ask that. Okay, I mean, just taking a shot in the dark, and I wrote down smss.exe, and that happens to be the PID, or that's what was attached to this PID, which to me, it's very odd that that would even be listed because it's not in the machine that we're using, and it's not anywhere on the screenshots here. So it's kind of weird. Non-existent process. Oh, here we go. So it's in here, right? So that's where it is. So if they're saying that the parent of this is the SMSS, and right here it says non-existent process 488, that's what we can refer to. And non-existent process 384, that's what we can refer to. So that's what they were referring to in this particular exercise. And if it's the parent process of CSRSS, that means it is the SMSS parent. So that's what that means. So now moving into wininit. All right, wininit, the Windows initialization process, also known as wininit, is responsible for launching services exe, the service control manager, lsass, the local security authority, and lsass, whatever, with session 0. It is another critical window process that runs in the background along with all of its child processes. And lsass is a process associated with credential guard and key guard, and you will only see it if the credential guard is enabled. So if it's not enabled, we shouldn't see it, right? So going into our process manager and process hacker here, let's try to look at what is normal and what is not normal. So going to look for the wininit first and foremost, and I'm gonna change it by name again so we can try to find it that way. I forgot how it was originally organized, so I'm just going to go back to here. And so here we go, we got wininit right here, and we're going to open this up. And what's supposed to be normal is that this is the path, so that's the normal path. The executable should be this, the current directory should be this, started exactly when we started the machine, and the process itself should be, it says a non-existent process, which means it needs to be the system itself, I guess. And so in this particular situation, it would be smss. And so for us, it's 560. So if we were to look at smss, it should be 560. Nope, it's not, it's 460. So let's see what's PID 560 in this situation. And maybe that'll help us kind of narrow this thing down. There is no PID 560. That's what's weird about this, man. It's like, what are we talking about here? Okay, fine, whatever. So wininit is right here, and then if I find wininit, oh, there we go, boom. It's like right there on the screen. If I find this and maximize that, so if I do by process, or can I do, I want to go back to the point where I could actually see everything that's under wininit, and it won't show me. Oh no, is that it? I think that's what it is. Yeah, it doesn't seem like that is what it is. So if we click on wininit right here, same command line, same current directory, same on the path. So all of this stuff is good. I just made the mistake of, I'm just going to close these out so it resets everything. But I made the mistake of organizing by PID to try to find that PID. And so here we go, wininit, is it organized by, oh, it's still organized the same way, son of a gun. And same thing with the process hacker. So now we are in a little bit of a challenge, I guess, because I forget what the original organization was for this, but whatever, that part doesn't matter. So that's kind of what it looks like, and we need to know that that's what it looks like. So that's the actual path. It should be created by an instance of SMS, which we already saw. There should be one instance of it. It should be on the local system, and it should start within seconds of us starting the machine. So what's unusual is that there's an actual parent, so calls this process and self terminates. So if there's an actual parent, that means it's not going to be no non-existent process. That's not going to be that. Image file is other than system32, subtle misspellings, multiple running instances, and it's not running as system. So which process might you not see running if credential guard is not enabled? And that process is right here, which is lsass, whatever that, how you pronounce that. That is what would not be running if we don't have credential guard enabled. So that was a quick one, wininit, and now we can move on to wininit, the services.exe underneath that. So the next process is the service control manager, also known as SCM or services.exe. It is primarily responsible to handle the system services, loading services, interacting with services, and starting or ending services. It maintains a database that can be queried using sc.exe, and we've done this a lot. So we've actually used this to start and stop services on the pentest plus pathway, because you can do a lot of things with this to gain escalated privileges or to gain remote shells and stuff like that. So it is a very, very important process. It is in the registry under this path, and this is kind of what it looks like. These are all the services that would fall under that. It also loads device drivers marked as auto start into memory. When a user logs into a machine, the process is responsible for setting the value of the last known good control set, last known good configuration, which is also in the registry, and it sets the value for us. And then we have, what is this? So it's under here, system select, and then last known good would be under there. But you can also just go to that path directly by typing all of that up. And it is the process is the parent to several other key processes: the SVC host, spool, MSM, DLL host, just to name a few. And we can read more about it there. What is normal is for this to look the way that it does here, and what is not, and it should be a session 0, it says, and what is not normal would be anything other than that. So let's actually go and try to confirm that's actually what ours looks like, right? So we're going to go over here, and we are looking for services.exe, which would be under S in this particular situation, and there it is, services.exe. And so far it looks normal, so it's inside the system32. The path command is the same, it's inside system32 for the current directory. It started when we started. Wininit is the parent, and that's exactly how it should be, and that's it. And so if we went to the token just to look at the session, it is also session 0. So all of it is all good. And so now if we go here, how many instances of service.exe should be running on a Windows system? And we can say that it should be only one instance. And that is all good. So now we can move on to wininit services svc host. The service host, the host process for Windows services, is svc host, is responsible for hosting and managing Windows services. Services running in the process are implemented as DLL, and the DLL to implement is stored in the registry under parameters in the service DLL. The full path is this, and it's whatever the service name would be, and then under its parameters. So for example, dcom launch would be under services dcom launch parameters. And then to view this information from the process hacker, we can right click on the service host process, and in this case it's PID 748 and whatever they're looking at over here. And then we can go services, dcom launch, and go to service. Right click the service and select properties and look at the service DLL, and that's what it looks like over here. From the above, the binary path is listed. Also notice that it's structured. There's a key identifier, which is -K, so it's right here. This is how a legitimate process is called. The -K parameter is for grouping similar services to share the same process. The concept was based on the OS design to reduce and to reduce resource consumption. From Windows 10 version 1703, services grouped into host processes changed. On machines running more than 3.5 gigabytes of memory, each service will run its own process, and you can learn more about that over there. So back to the key identifier from the binary path, the K value is dcom launch. So other services running with the same binary in the virtual machine attached to this form, this room. Each will have a different value for service DLL. And so let's take LSM. So again, right here, right, LSM as an example, and inspect the value, which is right here, system root, system LSM DLL, and then LSM properties, which should match exactly to that. So since service host will always have multiple running processes, the process has been a target for malicious use. Adversaries create malware to masquerade as this process and try to hide among the legitimate service host processes. They can name the malware servicehost.exe or misspell it, such as service SCV host instead of SVC host. By doing so, The intention is to go under the radar. Another tactic is to install or call a malicious service DLL. Extra reading would be in the hexacorn blog. So what is normal would be all of this right here, meaning the image path is at system32. The parent process is services.exe. There's a lot of instances. User account varies, so it could be the system, network service, local service, depending on the instance. In Windows 10, some instances are logged in user, and start time is same, several seconds of boot time. What is unusual? Parent other than service, other path, subtle misspellings, and the absence of the K parameter. So what we're going to do is we're going to go and search for, what is it, svc.exe, servicehost.exe, excuse me. So we're going to go here, we're going to go down here, and look at that. There's a bunch of different instances of servicehost.exe, and it all matters. It all could be pointing to different things. The one thing that needs to be is that -K that's there, and the parent is system32. The current directory is that, and it could be pointing to really anything. So if I right click on it and go to services, and then there's a bunch. So this is the one specifically, LM host, that's attached to this. We can also have the event log. We have DHCP that we can go to, time broker service we can go to. So there are a bunch of things that are under this particular one. So if we right click on another one, and if we go under, where is it? Services, there we go. These are all the services attached to this one. And so I guess they're, similar services, right? So if we go under services for this one, these are the two services attached to that one. And so this is kind of how it looks, right? So you go to services for this, DHCP, let's go IAM host, go to service, and it'll open it up under services, not processes. It'll open it up under services. And then we can see it here. If we double click on this, it'll open it up, and it'll say it's pointing to its individual DLL in there, and it has the K parameter, so all of that. So looks good. Looks like this system hasn't been hacked. So now what is the question here? It says, what single letter parameter should always be visible? And that is K, my friend. So moving on to lsass.exe. Per Wikipedia, the Local Security Authority Subsystem Service is a process in Microsoft Windows operating systems that is responsible for enforcing the security policy of the system. It verifies users logging onto a Windows computer or server, handles password changes, and creates access tokens. It also writes to the Windows security log. It creates security tokens for the security account manager, Active Directory, and net logon. It uses authentication packages specified in this registry, and you can see all of the right here. These are the various things that are attached to it, and we have Kerberos in here. So it seems to be a very important one. It's another process adversaries target. Obviously, common tools as Mimikatz are used to dump credentials. We did that in the last video for I want to say lateral movement or something like that, to hide in plain sight. Again, we do this by either naming it different or by actually using the process name or just a simple misspelling, so on and so forth. Extra reading, how lsass is maliciously used, and additional features that Microsoft has put into place to prevent these attacks. And now we have what is normal. So the pattern is the same, right? So it should be in the system folder. The parent process should be exactly what it is. There should only be one instance. It should be only on the user account, which is the local system, and within seconds of boot time is when it should be starting up. So a parent process other than wininit.exe would be problematic. Image file other than what's under system32, subtle misspellings, multiple running instances, and not running as system. So what is the parent process for this? It's going to be wininit.exe, and that's the answer for that. So moving on to the next particular one, which is winlogon.exe. Windows Logon, or also winlogon, is responsible for handling secure attention sequence. It is the Control-Alt-Delete key combination people press to enter their username and password, right? So when you start the computer, it typically asks you to do that so that you can enter your username and password. It's also responsible for loading the profile. It loads the NT user database into HKCU and the HK current user, that's what that is, and user init loads the user's shell. And more about that could be on that link. And so this is what the registry looks like. If we go under winlogon, we can see that the shell is running as explorer.exe. User init is running at user init under the system. It's also responsible for locking the screen and running the user's screensaver, among other functions. You can read more about it. And the earlier sections that we saw, smss launches this process along with a copy of csrss within session 1, which is the user. What is normal is for it to look like this: be in the system, have a command line winlogon. The current directory should be that. It should start exactly when we started, and there should be no existent processes because it belongs to SRSS. And since it is under the user and not the system, it would be session 1 instead of session 0. So all of these things are here. It could be one or more instances, local system, instance of SMSS. Analysis tools usually do not provide the parent process name. Within seconds of boot time, additional instances occur as new sessions are created. What's usual or what is unusual is an actual parent process. Image file could be something other than system32, subtle misspellings, not running as system, and the shell value is something other than explorer.exe. So what is the non-existent parent process for winlogon? And it would be smss.exe. Okay, pretty straightforward. And just in the interest of time, that's the reason why I'm not going into this tab and looking at these things, because we're running a virtual machine inside of TryHackMe. So I am almost 100% sure that this thing is exactly how it should be. It's configured as it should be. So I'm not really concerned about that part. So we just need to really understand where it is, what it does, and what is normal and not normal for this thing to be running. So let's move on to our very last one, which is explorer.exe. All right, explorer.exe is the Windows Explorer. This process gives the user access to their folders. It also provides functionality for other features such as start menu and the taskbar. It should be under the user init, which launches the value inside of this registry. User init exits after spawning explorer.exe. Because of this, the parent process is non-existent. So explorer.exe, you have task manager that's under it, and pretty much anything else that would be under that file explorer, right? The Windows Explorer. What's normal is for it to be under Windows itself and not system. So Windows Explorer, the command line is explorer.exe. The current directory, I guess, would be the system32 directory. It was started when we started, and there should be no parent process or no existent process. So that's the image path for it. The created by the user init, and it exits immediately. So one or more per interactively logged in user. The account would be whoever the user is. First instance is when we started logging in, right? It's an actual parent process would be unusual. So user init calls this and then exits immediately. Image path other than Windows, running as an unknown user, subtle misspellings to hide it, and outbound TCP IP connections. That's a new one. So if, let's see what this is right here. Resolve address protocol remote state TCP IP should be none right here. So if we actually went in that environment and checked that out, and I think this is for the process manager. So I do want to check this one out because I'm interested to see what that looks like. So if I go to Windows Explorer, is that what it was called? Oh man, what is it called? Explorer.exe. Okay, got it. Explorer.exe right here. Open this thing up, and TCP IP right here. It should be nada. There should be no connection to anything whatsoever. And so that's all good. So what is the non-existent process for explorer.exe? And that would be the user init.exe. And that's correct. Okay. Sounds good. And we just went through all of the core Windows processes that we should be concerned with as a security analyst, a system analyst. So let's jump into the conclusion and then we'll wrap up the video. All right, so in conclusion, understanding how the operating system functions as a defender is vital. The Windows process discussed in this room are core processes, and understanding how they usually operate can aid us in identifying unusual activity on the endpoint. With the introduction of Windows 10, new processes have been added to the list of core processes to know and understand the normal behavior. Earlier, it was mentioned that if credential guard is enabled on the endpoint, then an additional process will be running, which will be a child process to winit, and it's called this, right? lsass, whatever. The process works with lsass to enhance password and protection. Other processes with Windows are runtime broker and task host, formerly taskhost.exe and taskhost.exe. So if we research these things and understand anything and any other processes that you think we would be curious about, and this is something that I'm pretty sure is just, it could be a mastery class or a master class in itself, because there are so many things that are running on that list, and one by one you could just be learning about them. So the information from this room has been gotten from any of these things. So there's the Microsoft documentation, sans.org, which is a big one, and of course GitHub itself. So there's a lot of stuff that we can be learning about this, and I mean, I highly recommend that if you're interested in becoming a security analyst or system administrator, that you learn everything that there is to know about the core processes, just so you can understand how it all runs and what should look like and what it shouldn't look like, right? So that being said, we are now wrapped with this room. If there was anything that you learned from this room, or if you found any value from it, if you liked the way that I teach, whatever it is, I would highly, highly appreciate and kindly request that you could like, subscribe, turn on the notification bell, share the video with somebody that might be interested, leave a comment. Any of those things would help tremendously in gaining privilege and gaining what do they call it? Favor with the YouTube algorithm, so that we get more reach on the channel and get more people to see the stuff and grow the community. And that's really all I ask from you in return for putting these videos out, so that you can learn from them for absolutely free. So not to guilt trip you, but I'm kind of guilt tripping you. And that's really all I can ask. So that's all I need from you, and that's all I'm going to say about that. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. If no one else loves you, Hank loves you. Peace, love, and chicken grease. And I will see you in the next room. Later.